So what is the z-score, or can be said to be a standard score symbolized as Z? So what is that one? So a z-score is said to be a value obtained by subtracting the mean from the value and dividing the result by the standard deviation. That is said to be a z-score, and basically it tells us how many standard deviations a data value is above or below the mean for a specific distribution of the data values. So that's what you call the z-score or the standard score. You should have to understand. Let's say we have we have a data value. Let's say we have, should be this case. Let's say we have the data value given as a 5, 10, let's say a 20, let's say it should be a 15. So you understand that the z-score is one of the measure of the positions. And let's say we are in the class of, let's say 60 students, and a student 1 has, let's say, scored 90% of, let's say, a certain test, and the other test has scored about, let's say, 45%. So now you see that we can be able to compare the relative, we can be able to compare the relative position for the two scores, that is 95%, 90%, and also 45% using the z-score. That is the measure of the position. And of course, in a little sense, we cannot be able to compare the marks. We cannot be able to compare the performance, let's say 90% as well as the 45% in an open case, because it may be that this test was this test was relatively, let's say, a simple compared to this one. Can be that, or there may be some of several factors that may end up having scored this grade and also this grade as well. But statistics and will help us to relatively compare the two scores using what we call the z-score. That is the measure of the position, or can be that. Let's say we have this data value in that case. So what is the z-score or the standard score, let's say, for 10? And what is the z-score? Let's say, now it should happen this way. What is the z-score? Let's say for 5. And what is the z-score, let's say, for 10? And what is the z-score for 20? And also, what is the z-score for 15? So take note of that. How should you be able to have all these things in that way? So now the formula for z-score, it is given as the data value minus, now should be the data value minus the mean, and divide by the standard deviation. Let's say if this is for the sample space, and whereas if it is the population, it means we'll have the data value minus the mu divided by the sigma, which is a standard deviation for the population. So take note of that. So what we need is to have the mean of the data as well as the standard deviation. So let's think of having the mean. Let's say this is the sample data. What is the mean? So x bar will be given as the summation of the values divided by their frequency, in the sense that we'll have it as a 5 plus should be 10, should be this, a 5 plus 10 and a plus 20 and a plus 15, and which is given as 50. So have it as a 50 and divide by how many values are here? We have them as 4. So divide by 4. That will be given as 12.5. So that is the mean, which is given as the 12.5. Then what is the standard deviation? So this is the x bar, which is the mean. So what is the standard deviation? Let's think of using the range approximation of the standard deviation, which is given as the range divided by 4. So in this case, what is the range? We'll have the highest value, which is given as 20, minus the lowest, which is given as 5, and over divided by 4. And what is that one? We'll have it as a 15 divided by 4, which is given as 3.75 in that case. So which means that is the standard deviation, and that is for the sample data. So bear that in mind. So that's the standard deviation in that case. So what is the z-score for 5? So which means we'll have the x value, which is 5, minus mean, which is actually 12.5, divided by the standard deviation, which is given as that. So you'll be able to have the z-score in that way. And likewise, you also have this one, and for that and that one as well. So take note of that. So here is the task for you. When do you expect, let's say, should be, when do you expect the z-score to be equal to 0? When is that? So this is the task for you to go and check that one out. It can be from whichever the source of your interest. So now, as you can see, it simply shows that actually the z-score, let's say the z-score, which is given as the x, actually the data value minus, let's say, the mean of standard deviation. So now you have to understand that if the data value increases, it means the z-score also have to increase, as you can see. So, but just have to know how you can be able to have the z-score in that way. And of course, this knowledge will also be very important when we're looking apart the normal distribution and some other concept related to that one. So thank you.